This section is all about weak bases, and we abbreviate them as WB. I should have put this right at the top, and that maybe would have set the stage. We can do all the same calculations that we do with weak acids. When you have a weak base, it'll either have a pair of electrons or it will have an anion charge. It will react with water and become protonated and produce an OH minus, which makes a basic solution. It has an equation for the Kb, and the Kb is called the base dissociation constant. For the amines, there is a lone pair of electrons that can accept that H+, and again, here is an actual example. Please familiarize yourself with it. Well, you may say, it doesn't appear anywhere in the real world. Amine hydrochloride is an active ingredient in all these over-the-counter remedies. Amphetamine is actually a weak base, and here we have amphetamine hydrochloride. Cocaine is a weak base, and there's its Kb. So why don't they just have them as the substance themselves? Well, when you make an ionic salt, it is much, much less volatile, it is more stable, and the ionic salts are soluble in water. Over the years, I kind of wondered, what is Adderall that many of you tend to take? It is really a mixture of 4 different chemicals in different proportions. Okay, so that shows you weak bases are very real. All right, in your textbook is a table with the bases and their structural formula. What is their conjugate acid and what is their Kb? There are 2 different kinds. The ones that are above my squiggly line are weak bases. They have lone electron pairs. The ones below the line, they are anions of weak acid salts. Since students struggle with this, look at the next slide. If I have an amine, it has a lone pair on the nitrogen. The basic molecule is ammonia. I can replace H with a methyl group. I can replace H with an O with a OH group to make hydroxylamine. Familiarize yourself. You will use a lot of this when you take organic chemistry. The other type of base is a weak acid anion. You know that HClO is a weak acid. NaClO is the salt. It dissociates 100% to make Na plus and ClO minus. That ClO minus can react with water to make a basic solution. So we've got a lot of calculations to do, but what I've noticed is students will struggle with what are these things. So this is a new addition this semester. In this chapter, we do 2 sections. In this section, we are going to find the pH of a solution. No, we are given the pH of solution. We are going to find the Kb, just because there's all these calculations you can do. In chapter 17, we will be doing Kbs for anions of weak acids and other calculations. I wanted to do one of each calculation while we were still in this chapter. Okay, so here is my weak base amine calculation. Normally, I write the numbers. There are just too many. What I want to do is talk through them. It says we are given the pH of this weak base. It is methylamine, and it is 11.81. They want us to determine the Kb. What are the steps you take? Well, pH is not going to do you much good. When you write your equation that you will be putting in and making an ice table, you need to have an OH minus calculation. So what I did is I said, okay, I'm going to find the POH. If I type 14 in my calculator and subtract 11.81, I'm going to get the value of POH. If I then raise that to the 10th power with a negative sign, I can immediately get my concentration of, well, it's both this as well as OH minus. Again, I have the OH minus in the front, but as you see in an ice table, they are in the exact same position. I did not make a blank because it's just too long. So this would be the first number that we get, our OH minus. We work backwards to get one of the change lines. Here we know it's a 1-to-1. We get the other change line. Here's another 1-to-1. We get the third change line. Then we do just what we did in the last chapter. We mathematically put these together. They will make our equilibrium concentrations of our methylamine, of our methylamine salt, and of our OH minus. How did I get that number? I always like to write it down here because students ask, and that's where that number came from. Then all we do is we're doing a KB calculation. We use our equilibrium values from our, and we come up with our value for our KB. So I hope you just don't Google this. I hope you take time and work through it because it's the process that's really, really important. That's all I can say about this. The last one is a challenging question, and it often appears on a midterm. So I want to make sure that I go through it as we're sitting in our lecture Zoom. Here is the NaClO, the sodium salt of the ClO minus ion. When you put it into water, here would be our first equation, it dissociates into two ions. That anion, ClO minus, is the anion of a weak acid. It is going to react with water to make HClO and OH minus. So that's really the chemistry behind it. Now, in order to solve the problem, they say we have a solution that has a pH of 10.25. How many moles of NaClO were added? So this is a more complicated problem. I sketched out here the two chemical equations that describe what's going on. Now we want to be able to make the equilibrium line in an ice table. We know that we need to have a concentration of OH minus. We have been given the H plus, well, we've been given the pH. If we can find the H plus, we can readily find the OH minus. More than one way to do it. I happen to do it this way because I just found it to be easier. Here is our H plus concentration. Here is the molarity. How did I get this? I did Kw divided by H plus. So again, this is the prep work before you can find the E line of the ice table. I'm hoping that you're fluent enough that when I do this E line, you see where it comes from. This would be my OH minus. This would be my HClO. This is my ClO minus. I do anticipate questions here because it is different equations and students tend to be challenged just by the chemical reactions that are there. So again, how did I start this? Well, I took a look at the chemistry. This would have been my step number one. I said, what am I talking about? I have a salt that dissociates. I have an anion that undergoes a reaction with water. What did I do next? Well, next what I did is I took that pH that was given, the 10.25, I turned it into an H plus, then I calculated my OH minus. After I had that information, I was able to draw the E line of my ice table because I had those concentrations. That's my setup work. Once I did that, I knew my expression for Kb. It's products over reactants. I substituted in the actual values that I had and I solved the problem. Okay, so it is algebra, and what we come down with is a molarity X, which would be our amount of, let's see, what is X? X is the amount of ClO minus in terms of molarity. They were asking us for the number of moles, so we must multiply by the fact that there are 4 liters of solution. A challenging problem. I will talk about it in the lecture Zoom. I wish I was in class so I could stop and pause and ask questions of the room.